Okay, in these set of problems, we're going to graph linear equations using slope-intercept form. So recall in previous courses that slope-intercept form is this. It's y equals mx plus b. So that's slope-intercept form. So that's where you get the variable y by itself. Now the coefficient of x is your slope, so that's your slope, and this constant b is called the y-intercept. So that's where the graph will cross the y-axis. So that's where the graph crosses the y-axis. That's what we mean by the y-intercept. So it's going to cross the y-axis. All right, so for example, let's suppose we have y equals 2/3 x plus 2. All right, 2/3 x plus 2. All right, so this is in slope-intercept form. So make sure you understand that this linear equation, and remember this is a linear equation in variables x and y because y is being raised to the first power and x is being raised to the first power. So that's a linear equation. And remember the graph of a linear equation is a line. Okay, so since this is in slope-intercept form, the coefficient of x is 2/3. So the coefficient of x is 2/3. So I'm going to write m equals 2/3. The y-intercept is the constant 2. So my y-intercept is 2. So I'm going to say b equals 2. So m is 2/3 and b is 2. Once you find this information, then it's pretty easy to graph this line. You don't need to use a t-table like you've done in other courses as well. You can just use slope-intercept form. Okay, now keep in mind though that when we do talk about slope, and you see how we have this slope being a rational number. So remember, slope we can think of as rise over run. That's important to remember from previous courses, rise over run. So remember, if your rise is positive, you go up. If your rise is negative, you go down. So that's the numerator. The denominator is your run. If your run is positive, you go to the right. If your run is negative, you go to the left. Okay? All right, so let's look at this example. Now, you probably don't have grid paper like this, but if you have a printer, this is in Canvas, you can print out, or you can just purchase your own grid paper. Okay, so what I want you to notice here, it's important to remember. So the first thing you have to say this. You have to say that the slope is 2/3 and b is 2. So that's your y-intercept. So the first thing you do, remember to graph a line, you need 2 points. To graph a line, you need 2 points on the line. You need 2 points on the line. Okay? So, remember your y-intercept is a point on the line. That's a point. So the first thing you're going to do is graph the y-intercept. So the graph crosses the y-axis at +2. So here's +2. So I'm going to go ahead and enlarge this so you can see a little bit better. All right, so +2 is right here. So I'm going to put a dot here on the y-axis. Okay, so remember that's the x-axis, that's the y-axis. So +2. Okay, now I need one more point. Now here's how you find the point. You're going to find the point using the slope. So the slope is 2/3. So remember your rise is 2, your run is 3. Rise is 2, run is 3. They're both positive, so that's an easy kind to deal with. So from your point, from the y-intercept, not the origin, the y-intercept, from the y-intercept, you're going to go up 2 to the right 3. Because remember, rise over run. Rise means go up and down. Run means left and right. You go horizontal. Rise means going vertical. Run means going horizontal. So from your y-intercept, my rise was +2, positive, so you go up 2, 1, 2. My run's a +3, so you go to the right 3, 1, 2, 3, and there's your other point right here. Okay, it is going to say label. So if it says label, that means you got to indicate what those coordinates are of the point. So So this point here, the coordinates is 0, 2, not 2, 0. Be careful. Some students mess up with this. 2, 0 is here. That's on the x-axis. 0, 2, 0, 2 is here. Now this point, remember, to determine the coordinates, you start at the origin, you go to the right 3, up 4. So my coordinates here is 3, 4. And then all you do is draw your line. Now don't forget to draw the line. Some students mess up and they just plot the points, and all they've done was plotted 2 points on that line. They haven't really they have not drawn all those points. So if you look at this, I'm going to go ahead and use a ruler. And so draw a line going through those points like this with an arrow. And so that means that all of these points on this line, all of those points on this line is a solution to this equation. All right, so graphing a line, to graph, when you graph a line or when you graph any equation, you're finding the solutions to that equation. So anything graphed is a solution to that equation. So there's an infinite number of solutions. All right, so remember, when graphing a line or when graphing an equation, doesn't matter what kind of equation it is, when you graph it, you are finding the solutions. Or you're indicating the solutions. Okay, sorry. So when graphing an equation, you are finding or indicating the solutions. So this is the solution. All of these, there's an infinite number of those, is a solution to this equation. So when it says graph this line or graph an equation, in this case we're dealing with lines, when graphing these lines, this is what you do. But in essence, what you're also doing is you're finding the solutions to that equation. All right? Okay, so let's look at another one. So let's look at number 2. So this would be number 2. I'm going to go ahead and make this a little bit larger, a little bit smaller. All right, so this will be number 2. All right, number 2. So number 2, I'm gonna go ahead and write it in slope-intercept form already. So let's look at number 2. So number 2, we have y equals negative 3/4 x plus, let's say, 3. Negative 3/4 x plus 3. All right, so I want you to notice it's going to say graph, so you're going to graph this line. So, and the directions will say probably graph using slope-intercept. So graph using slope and intercept. All right, so if it says that, you got to first of all make sure this is in slope-intercept form, and it is because y is by itself. So once you do that, you're going to say this. You're going to say, well, the slope is going to be the coefficient of x, so that's negative 3/4. Okay, negative 3/4. Now don't say. So some students do this and you lose points. So don't say the slope is negative 3/4 x. That's not true. So don't put that x there. The slope is the coefficient of x. So you just got to say negative 3/4. If you say that, you're not going to get all your points. All right, and then the y-intercept is this constant, which is 3. All right, once you find that, we're going to graph the line now. So let's graph. So there's going to be y equals negative 3/4 x plus 3. All right, so to graph a line, remember to graph a line, you need 2 points in that line. The y-intercept is one of those points. So we do that first. So you graph that point first. So you plot that point first. So here's the origin. So the y-intercept is here at 3. All right, so let me go ahead and make this a little bit larger so you can see a little bit better. Okay, and then we need one more point to graph a line. So from this y-intercept, I'm going to use the slope. So the slope of this line is negative 3/4, rise over run. My rise is negative 3. So remember, rise means going up and down. So since my rise is negative 3, what I'm going to do is I'm going to go down 3. 1, 2, 3. So I'm right here. Don't put a dot there. You just hover over it. Now my run is a positive 4. Since my run is a positive 4, I go to the right 4. 1, 2, 3, 4, and there's my other point. Okay? And then all you do is just draw your line. And then you graph the line y equals you graph the line y equals negative 3/4 x plus 3. All right, so let me go ahead and draw this line. Let me use this red color. Now, a couple of things I need to remind you about, and that's going to be important because some of you can be upset if you don't do this and you lose points. It's going to say label the points. So labeling means telling me what those coordinates are. So this coordinate here of, and notice, I want you to know, see where it crosses 4, and that's on the x-axis, that's the x-intercept. So the x-intercept is where a graph crosses the x-axis. But the coordinates, though, is 4, 0. And here the coordinates is 0, 3. So that's what we mean by labeling. So labeling means you got to say this. All right. Okay. Now, one other thing I want to say is this. So you see how I asked you to graph this linear equation. It was already in slope-intercept form. I just want to say this, just to remind you of something. So suppose someone said this. Suppose someone said, well, I'm going to write the slope as 3 divided by negative 4. So instead of saying negative 3 divided by 4, they said 3 divided by negative 4. Okay, no big deal. It's still correct. It's still negative 3/4. This is still negative 3/4. So in this case, I want to show you something what's going to happen. So you're still going to plot your y-intercept, okay, just like this. Except this time my rise is a positive 3. So that means you're going to go up 3. 1, 2, 3. Okay? So from your y-intercept, you're going to go up 3. 1, 2, 3. And my run's a negative 4. So since it's negative, you're going to go to the left. So look, 1, 2, 3, 1, 2, 3, 4. And then notice that if you extend that line just like this, it goes through that point. You see it? So it goes to that point. So it does not matter. It does not matter whether if the slope is negative. It does not matter whether you make the rise negative or whether you make the run negative. It does not matter. You're still going to get the same line. You're still going to get the same graph. Okay. Now, when we label this, though, I want you to remind you. See, it's in the second quadrant. Remember, your quadrants are 1, 2, 3, 4. So it's in the second quadrant. So to label that point, you always start at the origin, and you do this. You go 1, 2, 3, 4. So negative 4. So my x coordinate's negative 4. And then I'm going to go up, and so my y coordinate is going to be 1, 2, 3, 4, 5, 6. So you see it corresponds to the 6, right? So 6. So you see this point? You see this point here? If you go down, you're on your x-axis, that's negative 4. That's easy to remember. On your x-axis, negative 4. On your y-axis, that's 6. So x is negative 4, y is 6. Okay? All right. Now, so that's that one. Now, I want to show you something with this now. Okay, so now what we have is this. So we want to graph this line using slope and y-intercept. Now, remember, the difference between this one and the previous two that we did was that when we graphed those, when we looked at the problem, y was already by itself. So it's already in slope-intercept form. Okay, so now what you have to do is you got to get this in slope-intercept form. So you must write in slope-intercept form. And so to write in slope-intercept form, you got to get the variable y by itself. And it's easy to do. You know enough algebra skills to be able to do this. So first thing you're going to do is you're going to keep this on the left side. So let's bring this negative 4x to the other side. So I'm going to say plus 4x, just like this. Then we're going to combine like terms. So when I combine like terms, that becomes 0. So I get 5y equals, and let's put the x term first. So 4x minus 10. Okay, so 4x minus 10. That's what this is. Then the next thing you do is you get y by itself. So you can divide both sides by by 5. You can divide both sides by 5, just like this. The 5's divide out, so you get y equals. Now what you're going to do next is you're going to put this. See how you want to make it look like like this. So you're going to rewrite this as two separate fractions. So you're going to say 4x divided by 5, or 4 fifths x. And then you're going to say minus 10 divided by 5. But reduce this. Reduce if you can. So you need to make this a negative 2. So I got y equals 4 fifths x minus 2. So now you wrote it in slope-intercept form. So this is slope-intercept form. Once you get in slope-intercept form, then you can graph it. So the slope is going to be 4 fifths, the coefficient of x. And this time, the y-intercept is a negative 2. So you got to be careful. It's not 2, it's a negative 2 this time. See here, see where you had plus 2, so the y-intercept was 2. You see where you had plus 3, the y-intercept was 3. Here, though, it's minus 2, 4 fifths x subtract 2, so the y-intercept's a negative 2. Okay, now, let's look at that. So now we're going to graph the line. So now we're going to graph this. So we're graphing the line 5y minus 4x equal negative 10. All right. Now remember, to graph a line, you need 2 points on that line. One of them you already know. One of those points on that line is the y-intercept. So one of those points on that line is the y-intercept. So let's go ahead and plot that point, the y-intercept of negative 2. So the y-intercept of negative 2, let me go ahead and make this a little bit larger so you can see it. So that's where the graph is going to cross the x-axis. So the y-axis. The graph crosses the y-axis, negative 2. So right here, negative 2. So I'm going to plot the point on negative 2. And then all I need is one more point. That's all I need. So I'm going to use the slope, which is 4 fifths, which is rise over run. And so they're both positive. So remember, you always start at the y-intercept. So you're going to go up 4, 1, 2, 3, 4, and then to the right, 4 fifths, and then to the right, 5. So up 4, 1, 2, 3, 4, 1, 2, 3, 4, 5. And so there's the other point. All right, and so now you're going to graph your line. And so when I graph that line, I get this line, okay? And so direction is going to say label. So to label, remember to label means to indicate the coordinates. So the coordinates are x, y. So this point corresponds to the x value 5 and then the y value 2. So 5, 2. This point here corresponds to the x value 0 and the y value negative 2. So 0, negative 2. Okay? Now, one other thing I want to remind you is this. So remember in previous courses, and it's a good idea to know this or to remind yourself of this. So when I looked at the slope here, this slope was positive, right? And this slope here is negative, correct? Okay, so I want to remind you of something. And remember, this was the graph y equals 2/3 x plus 2. So whenever you read a graph, and that's going to be important later on this week or next week, whenever you read a graph, you always read it from left to right. You always go from left to right. And so notice, as I go from left to right, my y values are increasing, or the graph is increasing. See how it's going up? It's pointing up. Okay, so here, remember, the slope was positive. So slope is positive, your line goes up. If your slope is negative, your line goes down. So as you go from left to right, notice those y values are getting smaller and smaller. See, 6, 3, 0, and so on. So your graph is falling. Okay, so that's how we sometimes say when we talk about lines. So I want to remind you of this. So let me go ahead and remind you of this. I'm going to put that here. So I'm going to put that here. So if the slope of a line is positive, the line rises. Okay? If the slope of a line is negative, the line, we say, falls. Okay? So it's actually, later on you're going to hear, you're going to learn about increasing, decreasing. So basically the y values are decreasing. So since it's falling, that means the y values are decreasing. Here, it's rising, the y values are increasing. So see, this y value is 2, then this y value is 4, and this y value would be some other number greater than 4, and so on. Okay? All right, now let's do one more. Let's do one more with this. So this will be number 4. Okay, number 4. So number 4, let's suppose we had this problem. Okay, so let's suppose we had 4y plus 3x plus 12 equals 0. Okay, now I want to graph this using slope-intercept. So let's graph this using slope-intercept. So the first thing we have to do, remember, is we must write it in slope-intercept form. Write in slope-intercept form. And so when you write this in slope-intercept form, we're getting y by itself. So remember, y equals mx plus b. And so I'm going to get the 4y by itself, so I'm going to bring these two terms to the other side. So when I bring those two terms to the other side, I get 4y equals negative 3x minus 12. Because I'm subtracting 3x from both sides, so that's where you see this negative 3x. And then you're subtracting 12 from both sides, so that's where you see this negative 12. Then the next thing you're going to do is you can divide both sides by 4, getting y by itself. And then the 4's divide out, so you get y equals, and then write this in as two separate terms. So we get negative 3x divided by 4, or negative 3/4 x. And then I want you to remember, a negative 12 divided by 4, that's a negative 3. All right, so that's what this becomes. Okay? So now you wrote it in slope-intercept form, and so now we know the slope. So the slope is a negative 3/4, the coefficient of x, and the y-intercept is a negative 3. Now, I want to remind you something. Before we graph it, the question I'm going to ask you is, will the line rise or will the line fall? When you graph it, will it rise or will it fall? Well, to determine that, you can look at the slope. Well, the slope is negative. So since the slope is negative, the line falls. Okay? All right, so let's go ahead and graph this. So remember, to graph a line, you need 2 points. The y-intercept is a point. All right, so let's plot the y-intercept. So that's at 0, negative 3. So I'm going to go ahead and plot this point here, put a dot here at negative 3. So that's the coordinates 0, negative 3. And then from that y-intercept, I'm going to use the slope. So the slope is negative 3/4 rise over run. So since my rise is negative, I'm going to go down 3. 1, 2, 3. Okay? 1, 2, 3. And since my run is 4, I'm going to go to the right 4. So 1, 2, 3. Since it's positive, I'm going to go to the right 4. 1, 2, 3, 4. All right, and notice that when I graph it, it will be a line that's falling. So let's go ahead and quickly graph this. And so when I graph it, remember when you're graphing all the points on that line. So this line has an infinite number of solutions. You're graphing the solutions. So every point on that line is a solution to this equation. That's what you're finding. Okay, but that's the graph. So when you graph an equation, you're finding the solution. So that's what the graph looks like. Now let's go ahead and label this point. So when you label that point, remember the coordinates of a point is x is first, y second. So the x coordinate is 4, so it corresponds to that 4, and the y coordinate is negative 6. So that's 4, negative 6. And you can always verify. You start from the origin, and so to get to this point, I've got to go 4 units to the right, and then 6 units down. So 4 units to the right, so positive 4, 6 units down, negative 6. Okay, now let's do one more. There's one more I want to do because you could see this as well. So let's do one more. Okay, so let's suppose we had this linear equation and you want to graph this using slope-intercept. What I want you to notice is this one. See where in all the previous problems the coefficient of y was positive? Here, though, the coefficient of y is negative. So don't let that throw you off. There are multiple ways you can deal with this if you need to. Okay, but the first thing you gotta remember is that you have to write it in slope-intercept form because you got to get y by itself. So write in slope-intercept form. All right, now two ways you can deal with this. Okay, so listen carefully to either way. So first approach is this. So first approach. So the first approach would be like we did the others. Let's go ahead and get this term by itself, and then let's bring this to the other side. So I'm going to subtract 3x on both sides. So I'm going to go ahead and rewrite this right here. So I'm going to subtract 3x on both sides. And so when I combine like terms, I get, this is 0, 3x minus 3x is 0, but I get negative 5y, so you got to be careful. It's a negative 5y, so don't make that mistake and say 5y. And that's going to be a negative 3x plus 20. That's what this is, negative 3x plus 20. Then the next thing you do to get y by itself, you divide both sides by negative 5, just like that. Negative 5 divided by negative 5 is 1. 1 times y is y. And then I want you to be careful with the next step now. So just like we did here, remember how we wrote this as two separate terms? Okay, you can do the same thing here. All right, now you got to be careful though. I'm going to go ahead and do this first. I'm going to say negative 3x divided by negative 5. Okay, negative 3x divided by negative 5 plus 20 divided by negative 5. All right, now let's simplify this. You need to remember that a negative divided by negative is a positive. So you got to say 3 fifths x. A positive divided by negative is a negative, so that's negative 4, or subtract 4. All right? So that's one way to get y by itself. The other way, I want you to look at this. So let me go ahead and rewrite the original problem. 3x minus 5y equal 20. What some students don't like solving for a variable in which the coefficient is negative. So what some students will do is they'll say, all right, if I'm trying to get y by itself, because that is slope-intercept form, if I'm trying to get y by itself, then I'm going to make this coefficient positive by bringing it to the other side. Okay, you can do that, no big deal. You can add 5y to both sides. And then when you combine like terms, you get 3x equals 20 plus 5y. But the problem also becomes this. Well, I got to now get rid of this 20 because I want 5y by itself. Okay, well, to bring this 20 to the other side, since that's a positive 20, you're going to subtract 20 from both sides. And so you get 3x minus 20 equals, this is 0, 5y. And then now, you remember how we divided both sides by the coefficient negative 5? Here you can divide both sides by positive 5, just like that. And then 5 divided by 5 is 1, so you get y equals 3x divided by 5, or 3 fifths x. And then a negative 20 divided by 5 is a negative 4. So you see you still get the same thing, right? You get the same thing. 3x minus 4 is y. 3x minus 4 is 3 fifths x minus 4 is y, and 3 fifths x minus 4 is y. So it doesn't matter which approach you use. Okay? But in any case, the slope is 3 fifths, and the y-intercept is negative 4. And so let's just quickly graph this one. And so to graph this one, now let me tell you what you're going to do in terms of your own paper. So some of you probably don't have this. You don't have grid paper. It is in Canvas, so if you need to print it, you print it. But what you're going to do is this. So let me just show you how you're going to do this on your own paper, because you got to show the graph. So what I would do is this. I would go ahead and draw an x-axis and a y-axis. Okay, so there's your x-axis, there's your y-axis. Okay, and then the next thing I would do is this. Since the y-intercept's a negative 4, you're going to do this. You're going to say negative 1, negative 2, negative 3, negative 4. So you're going to put a dot here. Okay? So I got to see something like that. I got to see those little tick marks. You must, if you're doing this by hand, you must use those tick marks. 1, 2, 3, and then 4. You put a dot on 4. Label it. That's 0, negative 4. Now before I go on, does a line rise or fall? Well, since the slope is positive, the line will rise. Okay, now the slope is rise over run, 3 divided by 5. So from here, I'm going to go up 3. 1, 2, 3. So that's where I'm at. And I'm going to go to the right 5. So use your tick marks on your x-axis. 1, 2, 3, 4, 5. Okay? All right, so I'm going to go 1, 2, 3, 1, 2, 3, 4, 5, and there's where your other point is. And so you label it, so that'd be 1, -1, and then you graph your line. So that's how you're going to do it by drawing it by hand. So if you don't have grid paper, then that's how you're going to have to deal with this. Okay, and so there's your graph. Don't forget to draw the graph. All right, so that's how you can do this by hand. All right, so let me go ahead and write the equation. This was 3x minus 5y equal 20. So let's remind you about something, okay? So this is how you can do this by hand. How do you do this by hand? This is what you're going to do. So let me do one more to show you how you can do this by hand if you don't have grid paper. So let's do a simple one. So let's suppose we had y equals 3x minus 5. Y equals 3x minus 5. All right, now I want you to notice that the slope is 3, coefficient of x. Now remember, 3 is the same thing as saying 3 divided by 1. The y-intercept's -5. So since, remember, you're doing this by hand, so you're going to draw your x and y axis. So there's the x-axis, there's the y-axis, and then you're going to plot your y-intercept, -5. So you're going to go down 5. 1, 2, 3, 4, 5. You'll put the dot here. Label your points. So that's 0, -5. You must label. If you don't label, you're going to be very upset because you're not going to get full points. Then you're going to use rise over run. My rise is 3. My run is 1. So whenever this is an integer, always write as a fraction. And so you're going to go up 3. 1, 2, 3. And then to the right 1. So make sure you put the little tick mark here, 1. So again, 1, 2, 3, 1. And there's the other point. So that's going to be 1, -2. And then you draw your line, and that's it. And that's all you do. So that's what you're going to do on your own paper if you don't have grid. But remember, you got to show those tick marks. If you don't show those tick marks, it means one of two things. Either you didn't look at the video, or if you did, you just didn't want to follow directions. Okay? All right, so be careful. All right, and that's it. So that was the end of this lesson.